This second half of 15.4 is just going to be applications that involve exponential or logarithmic functions. So it's nothing like too major. Basically, we just have like introduce you a situation, give you a formula, and we do story problems based on the formula. So just basically figure out how to plug stuff in. Okay. So an example of a real life scenario where the behavior is described using an exponential logarithmic function is measuring like sound intensity. So oftentimes we measure that in decibels. So the decibels is equal to 10 times the log of I over I naught, where I is the sound intensity measured in watts per meter squared. I naught is a constant. If you guys heard decibels used before? No? Any sports fans in the room?
Yeah, when they put it like on the jumbotron.
Yeah, they have like the sound monitor that's probably measuring things in decibels. That's the only time I think I end up seeing it is like, oh, it's louder than a jumbo jet taking off in here today, Pat. And Pat's like, what'd you say, Jim? You know, and like we ham it up for TV. All right. So an example, it says, given the sound intensity of a busy city traffic is 10 to the negative 5 watts per meter squared, what is the measure of busy city traffic in decibels? So we're asking to solve for beta. We're given an I, and we know I naught is a constant, always the same. So we're just going to plug things in. So far, so good. Now, you could just type this into your calculator. It would not be wrong to do that from here, but we don't really need a calculator to do that. So let's just do this by hand. How do we simplify 10 to the negative 5 over 10 to the negative 12? How do I simplify 10 to the negative 5 over 10 to the negative 12? Looking for some participation.
Do you have to like do like the exponents first? Like divide numbers or multiply them?
Not multiplying exponents here for dividing two exponentials. What do we think? Let me ask this question then instead. What's x cubed divided by x squared? X. How did you get x to the first? You subtracted the exponents. Let's do the same thing here. So what's negative 5 minus a negative 12? 7. Everybody's okay? Now, remind me again, when we write log with no subscript there, what is the base of the logarithm? 10. Right? We call that the common logarithm. And what do I know about log base 10 and exponent base 10? They cancel out. So we're left with then 10 times 7, or 70 decibels. What do you guys think on that? Easy squeezy? Yeah. And again, not unreasonable to just like type the original thing into your calculator and press enter, right? There's nothing wrong with doing that. Coolsville? On to the next guy. Why not? I love the attitude. The next example is the Richter scale. What do we recognize Richter scale from? Earthquakes. That's how we measure earthquakes. We've got some earth science scholars in here. So the Richter scale is designed to measure the magnitude of the earthquake. So R represents the magnitude, and then our formula is R equals log of A over T plus B, where A is the amplitude in micrometers of the vertical ground motion at the position the earthquake is measured. So they're talking about, like, if this is normal, right? An earthquake happens when two plates rub up against each other. So if this is normal, when we talk about the amplitude, it's how far displaced from normal that earthquake is. So like either whether it's slipping up or slipping down, right? It's that distance. T is the period of the associated wave. So again, remember period, if this is our start, the two plates just normal position, the period is the time it takes to slip down, slip up, and then return to the starting spot. That's what we mean by period. It's the amount of time it takes the plates to do that. And then B is a correction factor, just some constant that's associated with the distance away that our measuring tool is from the epicenter of the actual earthquake. So the epicenter is like ground zero, where the earthquake's actually happening. Funny thing about earthquakes is nobody can really predict when and where they're going to happen. So we can't have the measuring tool right where the earthquake's happening because we don't know it's going to be there. So our little seismograph or whatever we're using to measure our earthquake is often miles and miles away at some lab somewhere. This B is like empirically we figured out like, oh, like, you know, every blah, blah, blah far from the epicenter earthquake is the measured intensity decreases by some amount, and we're able to create a correction factor based on distance. That's what the B is. So example 27 says the infamous San Francisco earthquake had a Richter scale magnitude of 7.5. How many times more severe was the most severe earthquake ever recorded? The 1960 Chilean earthquake that had a Richter scale magnitude of 9.5. So we have an R1 and R2. And then it says how many times more severe. So the severity of the earthquake is going to be dependent on like that vertical displacement, right? The more rocking that there's going, the more severe the earthquake is. So if we call this, say we have an R1 that's associated with San Francisco, and an R2 that's associated with Chile, then how many times more severe would be like the ratio of A2 to A1, right? If it's twice as bad, then A2 over A1 should equal 2, right? Then if it's asking how many more times something is than something else, you're just talking about if I divide those two things, what number do I get? Is everybody okay with that? So we're going to be trying to solve for A2 over A1. So right away, well, I know I have a value for, this is so stupid, R1 and R2, right? It tells me them in the problem. And if I think about this now, remember, what does the B represent? The B was that correction factor for how far away the tool is from the epicenter, right? So all we're using that B for is to calculate the magnitude. If I already have the magnitude, what can I assume the B to be? Any number I want. What number would be a good number for b? Zero would be a great number, right? Let's imagine b is that our tool is actually at the epicenter. That's a great choice. Yes, go ahead.
Thanks.
Sure. Okay. Everybody's good with that? And how I was able to make that assumption that it was just zero? How about the t's now? Remember, what is t describing? T is the period, right? It's the amount of time it takes for our plate to go like this, and then back to the start, right? Everybody's okay with that idea? Do you think that's going to be a short time or a long time? I know you've never been in an earthquake before, but you've probably seen it on a TV show or a movie. So like when the earth is shaking in a TV show or a movie, is it like, does it shake really slow or is it happening really fast? It's happening really fast, right? Do you think that time it takes for the plate to go like this, is that going to be a short time or a long time? It's probably really short because it's going to go like, it goes like this, right? Everybody agree? So guess what? If T1 and T2 are both really, really short, what can I say about them? Basically the same. So we're going to assume that also. So we're just going to write those as like T. Just going to kind of assume they're the same thing. All right. So far, so good. So now I've used some information like what I knew the formula is representing and thought about the physical phenomenon to justify like where some of this missing information came from, right? This is not like a typical question, but it's like a hard version of it because you have to rely on things maybe other than just mathematics to justify what we just did there. I know. So what I'm going to do now is I'm going to assume this is equation A and equation B, and I'm going to just do equation B minus A. So 9.5 minus 7.5 is 2. Everybody's okay there? What can I do with this? I have one log minus another log. What can I do with that? Again, here at this point, I'm looking for some participation. If I have one log minus another log, what can I use there? Give you a hint. It starts with a Q. Not the quadratic formula. Coefficient starts with a C.
Good try. Quotient.
Quotient what?
There's a word after that?
Difference?
It's the quotient property for logarithms. If I have the difference of two logarithms, I can rewrite that as the log of the first argument divided by log of the second argument. Is everybody okay there? Good job coming up with the right keyword there. You're welcome. Look inside that logarithm now. Do you notice anything you can do?
Cancel out the T's.
You cancel out the t's, and since they're the same t, that's easy peasy. So now how do I get rid of the log out front so I can get the, oops, I wrote those in the wrong order. I need to fix something real quick. This one should be A2. This one should be A1. Okay. Sorry about that. Make that little fix there if you're following along. So I notice now that I almost have what I'm looking for, right? That we want A2 over A1. And I see it right now. I have A2 over A1. I just got to get that log out of there. How do I cancel out that log that's in front? I'm now looking for some participation again.
Times 10.
Close. Times is not the verb you're looking for. But we do need the number 10. So the word you're looking for is an exponent base. So I'm going to have 10 to the second equals 10 to the log of A2 over A1. Now, why did you choose the exponent base of 10, Grace?
Cancel the log.
Because the log base is also 10. Even though we didn't write it, we know it's there. So we end up with A2 over A1 equals 100. So that Chilean earthquake was 100 times as severe as the San Francisco earthquake, which is pretty nutso. This was like probably one of the harder problems you see, just because of all the little assumptions that we had to make about geology and about what's physically happening in order to get to the answer. But like once you've seen the trick, it's like, okay, the T's are the same, the B's don't matter. You know, can do this again if I needed to. Another situation described by exponential logarithmic relationships is pH. Where do you recognize pH from? Nobody? Chemistry. There you go. What does pH measure in chemistry class? Not the purity of the water.
The chemicals in the water?
Close.
Acidity.
Acidity is what it measures. Yes, the acidity of a solution. Often those solutions are aqueous. The pH scale ranges from 0 to 14, where 0 is most acidic and 14 is most basic. 7 is right dead in the middle. We say that's the pH of deionized water. We call that neutral. So our formula for pH is equal to negative log of the concentration of hydrogen ions in the solution. That's what the bracket H plus stands for in chemistry. When you put brackets around something, it's concentration, and then H plus is a hydrogen ion. So it says a really sour lemon is found to have a pH of 2.2, and a bottle of bleach is found to have a pH of 10.2. What are the hydrogen ion concentrations of the two items? Okay. Yes. Sure. So let's do the lemon first, since it was listed first. So I'm going to just plug in to my formula. I know the pH is 2.2. And I'm going to put a little subscript L down there for lemon. All right, so I want to solve for that H plus. What should I do first in this equation in order to solve for that H plus? I'm now looking for participation again. What should I do first to solve this equation for H plus?
Get it by itself.
Good. So the first thing I should do to get it by itself is? By?
Log.
No.
L.
No.
L.
L for lemon. What?
10.
10? No.
Divide by 8.
Nope.
10.2 divided by log. H plus.
Base 10.
Nope.
Quotient exponent.
Nope.
7.0.
Nope. The answer is -1.
Oh, I was close. Oh.
Why -1?
So you get rid of the negative.
I got to get rid of that negative sign that's attached to the log. And now what do I need to do to both sides? Now I'm ready to cancel the logarithm. What is going to cancel that logarithm? Base 10. Let's say base 10. Can we say that? Okay. So you guys all recognize that we're not multiplying by 10.
Did you just walk out?
And the concentration is usually given in moles per liter. Chemistry students, what is moles per liter also known as?
Moles per what?
Moles per liter?
Yeah, I got nothing.
Avogadro's salt.
No, man.
Moles what?
Moles per liter?
I just took notes on the
Moles per liter. What is that?
Molarity.
Yeah,
Oh,
I don't know.
Yeah, molarity. Okay. So if we want to do the same thing for bleach, what do? We do the exact same setup, right? I'm going to put a little B subscript on there for bleach. What are we going to get? I'm just going to skip all the work. It's the exact same work, right? We do the exact same steps. We're good skipping and just like writing the answer. It's like, I can see what happened. I just have like negative pH in the exponent of my number 10. Whatever, okay. That's fine, Mr. Kulik. Part B says, how many times greater is the hydrogen ion concentration of the bleach than the lemon? This has got to be a typo because the lemon definitely has more ions than the bleach. Everybody's okay with what I've done to fill in? What do I get when I simplify 10 to the negative 2 divided by 10 to the negative 10.2? Looking for participation again. What was that simplifying down to?
Well, I don't even know. What did you say?
Well, it's because you're on your phone or your calculator or something.
No, I'm on.
Or other homework. Okay. Sorry, excuse me for not getting the right distraction for you.
Okay, so what's the question?
I was asking how I simplify. What do I get when I simplify that I circled in yellow?
Whatever that is. Negative 2.2 minus? You already put it there.
Yeah, because no one was answering.
Is it because you subtract that?
Yes. That's all we did. So 10 to the 8th, what is that? That is like 100 million? 10 million times? 10 million?
100.
Is it 100 million?
Zeros.
8 zeros is 100 million? It's a lot more hydrogen ions in the lemon than the bleach. Like a lot. Like a lot. Everybody feel okay with what we did there, though? Again, mathematically, like the mathematics, pretty simple, right? Like not crazy. Everybody good? All right. This one is probably the most complicated situation. This is called Newton's law of cooling. This describes how objects that are heated up cool back down. So like, how many of you have ever like cook those pizza rolls in the oven. You get them out and you pop it in your mouth right away. What happens? You got like that lava cheese and burn the bejesus out of your mouth, and like you can't taste any of their pizza rolls afterwards. It's how they make them. They're so bad that I think it's part of the design flaws that if it burns your mouth and you can't taste it afterwards, you're going to keep coming back and not realize how gross these things are. This is me making a joke. I don't think that's actually the marketing plan, but. So Newton's law of cooling says that the future temperature of an object that's been heated up, that's the T of T, that's the temperature of the object at some future time T, is equal to the temperature of the surroundings. So like if it's I baked a cake and I set it on top of the stove, the surrounding temperature would be like the air in the room, right? If you're a medieval blacksmith and you're like making a sword and you dunk it in the cold water, the temperature of the surroundings would be like the cold water. Everybody's okay with what we mean there? The T naught is the initial temperature, so that's like how hot the thing was heated up to. So in the case of the cake coming out of the oven, it would have been the temperature of the oven, like 350 degrees or whatever. Or if you're the medieval blacksmith, it would have been like the temperature of the furnace, like 3,000 degrees or something it probably takes to melt steel. And then we have times e to the negative kt. K is a constant. That constant K is specific to whatever the substance it is that you're heating up. So the K for a cake would be different than a K for a sword, which would be different than like the K for, like glass, which would be different than the K for, like a pizza roll. Everybody's okay with that? And then T is a time. Typically that's probably going to be minutes, but it's going to be built into whatever the T or the K is, right? So the unit for K will match with whatever the unit for time is. It'll probably tell you, or it'll be obvious in the problem what it is, but typically the T is minutes. All right, let's read our example. So a hard-boiled egg is heated to 96 degrees Celsius and then placed in a pot of 16 degrees Celsius water to cool. After 4 minutes, the temperature of the egg is 45. How long will it take in total to cool the egg to a temperature of 20 degrees? Okay. So, sounds like I have a lot of information going on here, maybe more than is even needed to fill in the formula once, right? So, how hot we heated the egg up, that's got to be the initial temperature, right? And the pot of cold water has to be the temperature of the medium. That's where we're cooling the egg down to. So far, so good. But then we have this other, after 4 minutes, the egg is 45 degrees. So that's like a T of T. The T there is 4 because it told 4 minutes it took to do that. And then it says how long, so we're looking for a T to get to 20 degrees. So that's another T of T, but there we don't know the T, right? What piece of information is in the formula that we're not given at all? What other piece of information do we need for the formula that we're not given at all? This is a participation situation. What? Not E. E is a number. It's like that 2.7. It's the K. Yeah. So here's the idea. We're going to take this piece and use it to solve for K. And then once we have our K, we can use it to answer that question. So that's what we're going to start with. Is everybody okay with our plan? So my T of T is 45. The temperature of the surroundings is 16. My initial temperature is 96. My surroundings are 16. E is the number 2.71, yada, yada, yada. It's irrational. That's why we use a symbol rather than a number. Negative K, and the T there is 4. So we're going to solve for this number K. So far so good. How do I solve for K? What do I need to do? What's one way I could do this?
Plug into your calculator.
Great. When you say plug it in, what do you mean?
Like graph.
Yes! So I could graph this and look for an intersection, right? Let's do it that way real quick. So 45 is one side, and then the other side is this. I'm going to do 96 minus 16 in my head. Is that okay with everybody? No? Okay. It just was like a lot less buttons. Everybody good there? Now I'm going to fill in, I'm going to create a window now. Here, the window, or in our equation that we've written, K was representing X, right? Or X was representing K. No idea what K would be, but I'm assuming it's got to be a positive number. And I don't know, 0 to 10 sounds good to me. Now I'm going to do the Y's. The Y is representing temperature. What's the smallest temperature that this egg could cool down to? Probably not to 0. It wouldn't be wrong to do 0.
36.
How about 16? Why would the egg get colder than the pot of water it's in? Right? 16?
Wait, so what was the X?
X is the K. We don't really know what to expect for that, so I just 0 to 10 is probably fine. The Y is representing the temperature. The coldest that egg probably is going to get is the temperature of the cold water. It would be weird to put something that was hot into something cold and have it cool down colder than the water it was in. That would be a weird thing to have happen, right? The laws of thermodynamics would not be happy with you if that kind of thing happened. So I'm going to make that 16. Now, if you put 0 there, is that going to be wrong? No, it'll be fine. What's the hottest this egg will ever be?
45.
Nope. 96, right? That's how hot we heated it up to. It's never going to get hotter than that because the surroundings are colder afterwards. Everybody feel good there? And how I picked my window? That's the thing with if you're going to choose to do this by graphing. You got to be able to pick a window so you can find the intersection. We'll do it without graphing here in a second. Second, trace, intersect command, enter, enter, enter. We get K is about 0.254. Is everybody okay with that, how we did that? What if we didn't do it by graphing? What would I do first to solve this algebraically? To get K by itself. Following reverse order of operations, the first thing I want to undo is any addition or subtraction. Do I have any of that? Yeah. Yeah, what would I do? Subtract 16? Subtract 16? You could do the parentheses. I'm not going to count that because we're not undoing anything. I'll just, you know. Oh, that's a plus sign. My apologies. There's no T there in the formula. I mean, it's just like copying the formula, man. Okay. Now what? What would I do next? And again, like Avery, I did the stuff in the parentheses at the same time because why not, right? What do I do next?
Divide by 8.
Yes. Okay. Now what?
You do the lid.
Good. We got to get rid of the exponent base of e. To do that, we use the log base e, which is also known as the natural log, ln. And the last step would be to
Divide by -4.
yeah. So again, if we type this into our calculator, I'd have natural log 29 divided by 80. Make sure I close my parenthesis and then do divided by -4. And there's that same 0.254 number that we saw, that we got when we graphed. It doesn't matter to Mr. Kulik which one you do. No, man, I don't care. Everybody good so far? Yeah? Okay. Now that we have our K, we're going to be solving for T. That looks like F. So what we'll write now is we're going to write our new T of T is 20. And we know K. And now we're solving for T. How can we solve that equation? Same way, right? We could graph it and find the intersection, or we could solve it by hand. Let's say that we went ahead and solved it by hand. So if I did that, I have 4, oops, give me enough space here. Have the natural log of 4 over 80 divided by -0.254. Or you could graph it and find the intersection here. If I wanted to do that, this is 20 now. And this is 0.254 times x. And then the t is going to be some minutes, right? So again, x min 0, that sounds good to me. X max, well, what number do I know the time it's going to take more than? It's going to be more than 4 minutes, right? Because it only got to 45 degrees after 4 minutes. Everybody agree with that? But I don't really know how much more than 4. I'm just going to say, like, I don't know, 20, 30 minutes probably is plenty. I'd rather overshoot than undershoot because I want to be able to make sure I see the intersection. But I don't know, 20, 30 minutes is probably enough. Everybody okay? Everybody make hard-boiled eggs before? Takes them a while to cool down that pot of water. 10 minutes maybe. 20 is probably too long. So there's my thing. There's the thing. I'm looking for that intersection there. Second trace, intersect command, enter, enter, enter. 11.8. So again, either way of going about doing that, whether you use a logarithm and solve it algebraically or you graph it and find the intersection, is okay with me. Caution about using the graph to find the intersection is you got to be sensible about picking your window. Got to use a little bit of common sense there because sometimes that's the hardest part is getting in. Your calculator show you what you wanted to look at. You know what I mean? So far, so good. NBD. Okay, that stands for no big deal. You knew that. All right, we're going to move on to start section 15.5. We're just going to do a little toe dip in here and finish it up next time. In 15.5, we're going to be talking about the very applicable financial mathematics realm. So we're going to start off talking about interest. So there's two types of interest. There's simple interest, where the interest paid is always on the initial and always based on the initial investment. So if you have like 5% interest and you invested $100 and you kept it in that spot for like 3 years, you'd earn $5 the first year, 5% of 100, and then $5 the second year, 5% of 100, and then $5 the third year, 5% of 100. So you'd end up with like $115. Is everybody okay with the idea there? Now, for the record, nobody really does simple interest. Maybe you're like illegal bookie or somebody, but no bank or financial institution is dealing with simple interest. It's just not what we do. Anyways, the calculation for simple interest, the formula FV equals PV times 1 plus RN over 100. FV stands for future value, PV for present value, R is your interest rate as a percentage, and N is the duration of the, or really like the number of compound, or the number of interest payments. Typically, it's going to be years. So, if you invest $2,000 at a 6% interest rate, how much money do you have in the account after 3 years? So, $2,000 is our present value. 6% is our interest rate. How much total money? That's the FV. And the 3 years is our N. Yeah, sure. So 2360. Does everybody feel okay with what I did there? Very easy, just like plugging stuff into a formula, right? How much interest did we end up making in that 3 years? How much money did we make off interest? $360, right? My future value minus my present value should give you the amount of interest earned, right? I'm not going to write that down, but that's a question I think comes up in the homework a bunch of times, asks you how much interest was earned. But it's like, should be really obvious what to do, but just double check, make sure it's obvious for everybody, right? Now, what happens much more frequently is we use compound interest, where compound interest, the interest payment, isn't based on your initial investment. It's based on the current value in your account. So if we go back to that example of having $100, 5% every year, if it's compound interest now, the first year you get $5 in interest. The second year, you're going to get 5% of $105 as your interest. The third year, you'll get 5% of, again, whatever the account value is, $110 and some cents or something. Everybody okay with this idea? All right, so our formula for compound interest, FV is equal to PV times 1 plus R over 100K, all to the Kn power. Again, FV still future value, PV still present value, R still interest rate as a percentage, N still the number of years, K is a new parameter here from the simple interest formula. K represents the number of compounds per year. So if we say the interest is compounding monthly, K would be, you can participate here, 12. If it was compounding weekly, K would be 52 weeks in a year. If it's semi-annually, K would be 2. Would be twice in a year. Yeah, 2 years would be biannually. That'd be twice, or every 2 years. That'd be weird. Or if it was quarterly, it would be, K would be 4, right? 4 quarters in a dollar. All right. So same setup, right? We have our PV, we have our R. It says compounded annually, so K is just 1. Asking for the future value when N is 3. Do you think it's going to be more or less than the simple interest? What do you guys think? More. Do you think it's going to be a lot more or a little more? Any guesses? A lot more. Well, let's see. Now, I'm not going to bother putting the times ones in. Is everybody okay with that? 238203. So what, like 22 bucks more than the previous one, which ain't nothing. Here's the deal though. Over the short term, compound interest, not much different than simple interest as we're seeing. If instead of doing this for 3 years, if we did it for 300 years, let me just illustrate to you the difference. So that's simple interest, 38,000. Compound interest, 7.8 times 10 to the 10th. Which would you rather have, like 38K or like $700 trillion? Yeah, like that's the power of the compound interest. Short term, long term, ooh. What a difference that makes, huh? Shocking. It's like going to be that much. So when you said, is it going to make a big difference? You're right, but not over the short term, right? If it's only a couple of years, probably doesn't make that much difference. If it's like over a lifetime, ooh, that's a big difference. We talked about most of this. Here's some, again, these are for your Ks. K is almost always going to be given to in words. These are some common ways of displaying K. You know, annually, semi-annually, quarterly, monthly, weekly, daily. I think we kind of talked about almost all of these, but I'm going to put it here and write it down so that we said that we did it. You know what I mean? The next problem, suppose Jean invests $800 in a 7% annual interest rate account. How much money will she have in her account after 5 years if the interest is compounded annually, semi-annually, quarterly, monthly, weekly, daily? Bless you. You're welcome. Let's kind of see. So this is annually, $1,122.04. If I change that K to 2, how much impact do you think this is going to have? Is it going to be more or less? It's got to be more, right? How much more do you think? Just give me an estimate. $5, $100, $1,000? What do you think? Any guess? Somebody take a risk. Use that learner profile. We're an IB school. I'm making IB jokes. Can you laugh at these? All right, I'm just going to press enter since everyone's being shy. Yeah, $6.50. Not all the money in the world, but it's something. All right, let's change that semi-annually to quarterly. How much impact do you think it's going to make? You think it's more or less than $6? You think more? Okay. $3 extra. At least like $3.50 of increase. Well, let's change that to quarterly, right? Going from 4 to 12. That's a big jump, right? That's going to do some stuff, right? Think we'll get an increase of more than $3.50? Let's see. No, it's a little less than $3. It's $2.20 or something. Yeah, but what if I do weekly? That's 52. 52 is big, like way bigger than 12. And we got to do, what do we pick up? 80 cents, 90 cents. Again, it's still better than the, like as that number is getting bigger, it's still better than the previous one. But is it like the end all be all number here? No. The numbers that really matter in terms of things growing, interest rate and time. That's all else, like you can muck around with how many compounds you're getting per year. It's still 7% interest. Is it better to do daily than weekly? Sure. But it's not like I'd rather have like an extra percentage point of interest than compounding daily. You know what I mean? Is everybody cool with what we did there? And again, I didn't write any of this down because it was just like updating one number in my calculator. It just seemed easier to just look at the calculator. You know what I'm saying? All right. Here it says Mara has $1,000 and places it in a savings account with 6% annual interest compounded monthly. How long will it take before Mara has $4,000? Which formula am I going to be using? Simple or compound?
Simple. No, compound.
Yep. It says compounded in it right there, so we know it's compound interest. Okay, the $1,000, what number is that from the formula? PV. Okay. 6%, what is that? R. What are we solving for?
The year.
The T, yep. What's the K?
12.
Because it says monthly. And then what's this 4,000 then? It's the future value. Right, because we have to solve for T. There can only be one unknown. So we got to have future value somewhere in there. So 4,000 equals 1,000 times 1 plus 6 over 100 times 12 to the 12t. Everybody happy there? To solve this, we could graph, or you could do it algebraically. Let's just graph this one. So I'll do 4,000 in y1 and the other thing into y2. Okay. So X is representing what quantity? The T, which is time, right?
How do we know what the X and Y is?
Well, so Y1 is equal to 4,000, right? So what's Y? It's dollars, right? It's monies. It's the account value. The X, when I typed the X into my formula, where did the X go? It was in place of the T. So what's X representing?
The time.
The time, the years. Everybody okay? So if x is representing the time, what's the least amount of time? 0. Can't have negative time. And then we don't know how long this is going to take. What do you think's a reasonable guess here, though, for an upper limit? Like, what's time is certainly enough time for this to have happened? What do you think? So like 2 years, 50 years, 1,000 years? What's like a reasonable upper bound here? You think 10 years? I would go higher than 10. I think probably 20 to 50 is anywhere in there is going to be fine. I don't know how long it's going to take. I mean, I do. I have the stuff pulled up. I would just have put 50 here probably. And that's probably way too many, but I'd rather have too many than too little. Because if I have too little, I have to go back and change the window. If I have too many, it just looks kind of squished, and that's fine. I don't care if it looks squished. The Y is representing the monies. What's the least amount of money we're ever going to have in this account? What we started with. Okay, and what money do we have to have more than? Has to be more than 4,000. What do you want to put there? That sounds great to me. Let's do that. So there's my 4,000 line. Here's my curve. Might have just, I don't think we would have got it in 10 years. Right? 10, 20, 30, 40. Oh, so this would have been 10 here. We wouldn't have gotten it. Right? I looked at that and it's 4 times. It takes a long time to quadruple your money. So again, second trace, intersect command, enter, enter, enter. 23.2 years or so. Feel good there? Absolutely. I think this is our last example, if that matters to you. Yeah, I mean, it's whatever. You can go. I'm not saying not to. Just giving you some context. I don't want you to like walk out the room and be like, there's one more example. I could have stayed for that. Yeah. All right. Last example. Gwen has $600 to place in a savings account. What annual interest rate would she need compounded weekly if she wanted to have exactly $1,500 in 10 years? Okay. What type of interest is this? Compound interest. Okay. What is the 600? Okay. What are we solving for? Okay. What is our K? Okay, so what number is weekly? 52. And then what's this 1,500 then? And then the 10, what's the 10? The T. Okay, so we'll write 1,500 is equal to 1,000 times, or not 1,000, you dummy. Try reading the problem. Come on. Some days I just like want to throw this stupid OneNote through the... Anyway, sorry, I'm getting off topic here. So that's what I'm solving, right? If I want to solve this algebraically, note that the variable is not in the exponent. Do I need to use a log here? No way, Jose. I need to use, I guess it would be a 520th root to cancel the exponent. Or just type in there a calculator and graph it. It seems like a decent idea. Let's just do that. Okay, so 1,500. Now my x is the interest rate, right? So what would be good values, or what would be a good range for my x's?
Like 1 through 10.
0 through 10 seems like a good bet to me. I'd be surprised if we needed a bigger than 10% interest rate. That's a pretty massive interest rate. But keep in mind, like not unreasonable. I might go 20 if it were me. but let's do 10 just because that's what you suggested. The minimum is 600. The maximum, I don't know, something bigger than 1,500, probably 2,000. Sound good to you? Okay. So there's my 1,500 line. Here's my thingamajigger. Okay, no problem. Second trace, second trace, intersect command, enter, enter, enter. And we get 302%. What do you guys think? NBD on this stuff? That's good. So you can add, or well now, let's see, what's due this weekend? This weekend is the 37 through 130 if you haven't already done it. Some of us already turned that in. The delta math, if you haven't done that, you should make sure you do that. And then the following week, we'll start with 131 to 46, or 146, and we'll add into that. So this is not due Sunday. This will be next Sunday. What's due Sunday?
37 through 130.
And then delta math. Everybody cool? All right, I'm done now. Yay.